So I'll go ahead and introduce you, Chae. So Chae DeLaRosa is a Python programmer and student at Kalamazoo Valley Community College. And this is actually the second time I think you've given a talk on Pygame at the meetup, which the first time was really good too. He previously served in the US Army as a team lead, and he really enjoys, you'll see in a second, his passion for Pygame. So thanks, Chae, for coming and giving a talk on Pygame. Really appreciate it.
Yeah, no problem. Okay, so let me get you introduced to what we're going to do real quick. This is pretty much just a hobby for me. I love it. So I've been I put a lot of time into this just for developing my skills. Because I found that as I was learning programming, you know, there's so many different things you can do with it. It's a little too much. So this is one of those frameworks I found that was really simple to learn, and it's difficult to like be writing a game and not be able to come up with something else you could add to it. So you can just keep adding and adding. So I think this is a great framework for beginners to pick up and then just write something, right? Like a Space Invaders like this one, and then just keep adding different things to it. Like I added the background here, that's a little algorithm. I added the death animations, that's a little algorithm. So it's helped me a ton. And I think that it can help a lot of people if they are having problems practicing and they don't, you know, just want to do leak code all day or anything like that. So yeah, it's this is the website. Let me send. Okay, I will try to link all this stuff into the chat if I can. Not at the moment, I'm gonna have to go a little quickly, but this is the main website. So this is the wiki where you can read about it. The docs right here, very easy to read. Most of the docs I'll go to, it can be a little touch and go, especially if it's written in something else and then wrapped with Python, which a lot of things are. So I definitely recommend like coming into here and just taking a look at something that we go over and reading it to get a little comfortable. Okay, so we're gonna start this from scratch. So here, what I'm gonna do is I'm gonna make a folder right on the desktop. We'll call this Michigan Python. I'll link this repository at the end, and it'll have all the finished code and then all these links there. Okay, so create one folder and open in the editor. One of the excellent things about Python, you can just start right up. A terminal. Okay, so all we need to start this project is Pygame. So I'm going to, come on, Python -m venv venv. I'm gonna make a virtual environment. I got too many projects on my computer, so just to isolate it a little bit. There we go. ls, okay, there it is, and then we can activate it. We're gonna say source venv scripts activate, and then yeah, we have the indicator, so now we can pip install Pygame. And then pip list. And there it is. And that's all we need. That's our environment. All right, is there any questions on that yet?
No questions in chat yet?
Hi, I was just wondering if we can run like a Docker container. Is that easier, or this pip works fine? Later, if you have to install more dependencies and stuff.
I do not know. I don't use Docker, so I'm not sure how that relationship works. I should though, right? Yeah, no problem. Okay, so let's make a new file here, and I'm going to call this the main loop. Yeah. Okay. All right, so all we need to get started for Pygame is a window and a loop. So we're going to do the bare minimum here. We're going to import Pygame first thing, and then we're going to initialize it. So when we call pygame.init, that initializes all of Pygame's submodules. So if you're building something a little specialized, you don't have to initialize all the submodules. You can just call like pygame.display.init, and that'll just initialize the display, right? Or sound, you can initialize just sound. Okay, so we initialize. Now we need to make the display window. So we're going to call it display, and it's going to be of type surface. So pygame.surface right there. In order to create it, we are going to call pygame.display.setMode. Okay, this gets us our window. You can customize this window a lot. Okay, we'll go one argument at a time. So size, of course, is going to be the window. I'm going to do something a little smaller. Is the text okay? Do I need to bump it up a little bit? I feel like it might be a little small.
It's a little bit small.
Okay.
Could probably go up a notch. Thanks.
Yep. Okay, so size. Oh, let me get my 640 by 480, just for a small little window. It's not going to take up everything. So the next one is flags. This is where you can customize a lot of different things. Most of them are very specialized. So all I'm going to put in here is Pygame, and then it's a constant, and it's called scaled, like this. So that's going to tell the display to scale, to the window to scale depending on what resolution your monitor is. It's displaying it. So if I'm on a 1440p and if somebody's on a 1080p, you know, it'll scale right, so it doesn't look completely disproportional. You can also add flags there for different types of displays. There's software displays and there's hardware displays. It defaults to software. Hardware, you got to have a specialized backend, I believe, for that. So it's pretty much just software most of the time. Next one is going to be depth. That's the color depth. We can just leave that at 0, or color bit display. This is where if you have multiple monitors, you can choose which monitor you want it to go on. So we'll just leave that to 0 because I don't want it to go onto my other one. And then VSync is a request. If you have VSync and it passes whatever checks they do for it, then you will have a VSync display here. If you pass the 1, it'll request it, or 0 just to, you know, skip over that if you don't need it, or if your computer doesn't support it. Okay, now we have a display. We need a loop. So this loop is going to be the main game loop. That's why we call the file main loop. It'll run as many times as it possibly can each second. So I'm going to say while 1, just because it's a little, it saves us the operation instead of using a Boolean. So every loop we want to fill the display. That way we can see it. Okay, All right, we're gonna use our first color. So the color is gonna be a red, green, blue value. And then optionally at the end, you can put an alpha value. So you could have 4 values, 3 or 4. If you're making a surface that's not the display here, you can pass the flag source alpha right there, SRC alpha. And that will make it so that it reads the alpha at the end of the red, green, blues whenever you're trying to print something to it. Okay, so let me just put some, make a black screen. Okay, so 255 is going to be completely, it's going to be solid. 255 is a solid alpha, 0 completely transparent. Okay, so we're filling, and now we need to update. Update. Okay, so we fill the screen. Update actually draws what we have done to the display. So everything before update, we want to, or everything in this loop, we want to put before this update line, because this is what actually draws to the screen. Just going to update it. Okay. This also takes an argument, a rectangle argument. Let's see if I can get it to come up. It won't come up for me. Either way, it's a new method they added where you can update only certain portions of the screen if you want. So if you really want to optimize your game, whatever rectangles are changed, like particles or players, whatever, you can store them all on the list and then send those to update every loop. So you're only updating certain portions. You're not drawing more than you need to. And then, okay. Yeah. So now we want to check events. So we have a display, we're filling it, and then we're updating it. Now we need a way for the user to interact with this program. And that's kind of what the event queue is doing. So we're going to say for event, we're going to loop through the queue for event in pygame.event.get. And then we see here, this returns a list with the event class as the population. So every event here is going to be the of event class for Pygame. So that means that they have certain attributes that lets us check what is being sent to the computer. So the first thing we want to check is called the type. So event.type is going to be his attribute. That's how we can check if it's a mouse being clicked, if it's a keyboard being pressed, a touch screen being touched, you know, whatever kind of input it supports. So we're going to say if event.type is equal to pygame.quit. Okay, so this is if we're supposed to end the program. So when a quit event gets sent to the queue, you can send this manually or when we display the window, just like how most desktop programs have the X up here in the top right. When you click that, that'll send the quit event right here to the queue. We'll loop through it. And then if we get it here, we need a way to exit. So I'm going to go up here and I'm going to import a way for us to exit from system import exit. And that's a method that'll help us close our program because we're not using we can't just exit this loop from here. If we put a break here, it'll break the for loop, but I don't think it'll break our while. So I'm going to put exit. Now, if we don't check for an exit queue, it'll just run forever, right? And it'll kind of go into an infinite loop and it'll suspend and it'll crash. So you definitely want to make sure you write this in here. Okay, this should display. let's see. That should be all we have to do to make it come up. Yep. Oh. Oh, the display.
Hi, B.
Why is it? Pygame, yeah.
Hi.
You want to call it straight from Pygame. Yeah, so that's a little, I probably should have changed this name right here from this, but that's what it is display. So we're calling the Pygame display update here because they still have the main control of drawing. So we can tell it what to do, but their function is really what's going to do all that heavy lifting right there. And there we go. So we have a window. We can grab the top here and move it, and it works. It responds to us. It's functional. We can minimize it, bring it up, click the X, sends the quit event, and it's gone. Okay. Any questions so far? Okay, cool. So the next thing we need to do is make a particle. So we're going to make you know, a little effect on this screen so we have something to mess around with. So particle, I'm going to call it particle.py. It's just going to have one class in here, and it's going to be particle. It's going to be a model for what Pygame needs to draw. So if we go to here, now for this, I actually like to use something called a data class. So if you've never heard of this, they're really helpful for managing data. You don't need a init method. It just initializes them for you. So what you do is you put variables in like you would in C# or something more of a static language, where you don't have to actually you can initialize a variable without assigning something to it, right? So we need a color, and it's going to be a list, and it's going to have 4 ints for the red, green, blue, and then alpha at the end. We need a center, which is going to be a vector 2. And we don't have vector 2, so we're going to import that so that way this file recognizes it, and it's in Pygame. So we're going to say from Pygame import vector 2. And vector 2 is just a class that lets us, well, it has functions for managing different mathematical operations between, you know, 2 points, and it makes it easy to change. It makes it easy to move something across the screen without it stuttering. There's a certain way you have to do it. You have to like convert a float into an int, or else if you just go by ints, it's a little stuttery. So that kind of abstracts all that away. And then we need a slope. So what direction is this particle going to go in? We'll pass it and then just send it on its way. So tuple, and it's going to have an X and a Y. And then we just need one more, and it's going to be the radius of the circle. So Pygame wants to know, how big should I draw this? And that's going to be a float. Okay, so in order for this to work, we have to use the decorator data class. This automatically creates methods for us that makes it, it'll initialize all these variables, and then it creates a couple other useful methods for comparing data between classes, or like comparing classes. If you compare 2 data classes together, like 2 particles, and they have the same data in here, then they will return true. Just because they have the same data, not because they're the same instance. And then you can also make these frozen. So if you want to extract data, you don't want it to change in your program, you can set frozen to true. And now you know that, you know, whatever happens to, or wherever you're reading this data, it hasn't changed since when you loaded it. Okay. Now we need to figure out how to dissipate particles. We don't want them to stay on the screen forever, okay? So we're gonna make this in the post init. So after the initialization of all of these variables up here, this is gonna be called the post init. And the only thing we need to make here right now is a dissipation rate. And that's gonna be a float as well. Now I'm gonna use 5. I'm gonna use, I guess I should say this whole equation. 5 divided by self dot radius. So that's gonna make it so that the smaller the particle is, which is the smallest it can get is 1, anything under 1 for the radius will not display. So it has to be, radius has to be greater than 1. So the smaller it is, which is 1, the smallest it could be, the higher the dissipation rate will be. So the smaller ones are gonna disappear quicker. Okay. Now we need to access our alpha value. So we have an alpha here, but it's in color. So we need a way to access this. So what I did is I just made a property. Call it alpha. And it's going to return an int, and it's going to return the last index of color. So we're going to go into color right here at 3 and return it. And then to set it, we're going to make a setter. Self and value. Okay. And I think that'll be a float. And this is going to return nothing. Now, we could put some fail safes in here just to make sure that we don't get a value in the alpha slot that we're not supposed to get, and then it'll crash our program. So I'm going to say, I'm going to set a minimum value for the alpha to be until it just zeroes out. So I'm going to say if value is less than 20, then color 3 equals 0. So if it reaches, if it gets too low, just zero it out. And then I'll be checking for 0, or we can check for 0 later, so that we don't just have particles being populated and populated. We have a way to delete them. So we can check if the alpha is 0. If it's not even displaying, just delete it, right? Okay. So if value is greater than 255, which is our ceiling. The alpha cannot be any greater than 255. So if it is greater than 255, we will just set it to 255. Oh, the last one, we can just do a regular operation, which is color 3 equals value. Okay. Now, if we just use this setter to assign, it's not going to work. The reason I wrote it this way is because we're going to use minus equals. So the value that's going to be passed is going to have what we need in it to determine if it's in the range or not. Okay. Now we need an update. We need a way for this particle to look like it is moving. Okay. So we just need to update the movement and we need to update the alpha. So our movement is with center. So center, it's a vector 2. So it's going to have an x here. Yep. I'm going to say that plus equals the slope and the index of the x incrementer, which is going to be the first. And then just the same thing for y. Alpha dot slope and then the y position. Now last we need the alpha and we're going to minus equals the dissipation rate. Okay. So now it's moving. Now it will have its alpha reduced. So this is meant to be called every loop of the game, every frame. And that's all we need to model this. This should be good. We lost anybody? Any questions?
Quick question. So this particle will move from in a diagonal way because we are adding the slope values.
It will move whatever slope we pass to it, that's how it will move. And there's more on that later.
Okay.
We'll write it out. So it's
Oh,
just
okay,
going to
okay,
be, yeah. So if slope could be negative, right? So if you plus equals and it'll minus. So I just stay consistent and plus equals both of them so that when I'm passing slopes, I can just make them negative if I want them to be negative, and I don't have to worry about what's in particle.
Okay. Yeah. Thank you.
Yep. Okay. So I'm going to put this here in case anybody wants to look at that. Now we need one more file and I'm going to call this effects. Now in here, we're just going to put, I'm just going to put one method, but you could put more if you want. Methods that return lists of particles. Okay. So that means that we're going to make, this is the effects file here is where we're going to make functions that will, functions with like algorithms in them that will make a list of particles with everything already decided. So the color, the center, the slope, radius, all of that in a list. And then we're going to send that to main, right? And then main is just going to display all of it. So let's show you what I mean. Make one function. I'm going to call it get explosion particles. And then it just needs a start position. Start position, which is going to be a tuple, 2 ints. Oops. Yeah. Okay. Which is going to return a list. Oops. Of particle type, the class, which we don't have here yet. So we can go ahead and import that from our particle file, import the class. Okay, so now it's here. We're good to go. Okay, so the first thing we should get out the way, I guess, is making the list that we're supposed to return. It's going to be empty, of course, because we're going to append to it. And then, yeah, okay. Now, this is where we're going to do the math of this. So I'll probably brush over it a little quickly, just because this is something that you can customize. You don't have to use this method. You can write your own, make it return a list of particle and send it, and then it'll display. This is just something I thought up, and then it'll be in the repository too if you want to look at it. So what I did was create a tuple of tuples of directions that will send the particles where I want them to go in order to create this effect that we're going to see. Now, I'm going to call it directions, and it's going to be a tuple of tuples which contain 2 integers. Okay, so these tuples are going to be direction modifiers. So they're either going to be -1, 0, or 1. They're either going to let the value stay the same, they're going to zero it out, or they're going to make it negative. And that's what will change the particle from moving to the right to moving to the top right, to the top left. Yeah, so we'll just have to multiply by the directions in here. So the first one is going to be left, which is going to be -1 and 0. The second one is going to be 1 and 0, which is going to be the right. The next one is going to be 0 and -1, which will be up. The next one will be 0 and 1, which will be down. We have -1 next, which is going to be top left. And then bottom left is going to be -1, +1. Next one is going to be 1, -1. That's going to be top right. And then the final one is going to be 1, 1, which is going to be bottom right. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that is for the 4 corners of a square and then in between them. So 8 directions. Okay, so we have those modifiers. Now we need to start creating our loop here. So to make these particles look better, we're going to use some random colors. So I'm going to go up here and import random int from random, import randint. Okay, we're going to make a list of colors. Colors, list, and it's going to have a list. It's going to have all the ints that we use to make a color in our program. So oops. There we go. So we can randomize the first, what is it? Yeah, that's right. Yeah, the first 3 values we can randomize. I'm not going to randomize the alpha because that'll kind of ruin how the dissipation works. But okay, randint 20 through 230. So not the whole spectrum, but a section of it. I got rid of the extremes here. Randint, so the same thing. And then uno más, 20, 230, and then at the end we can just do 255. Okay. So we have a list here, which is going to take a list of this. Now, right now we just have 1 in here, but Python has something called list comprehensions. So this is what we want. We want it for, we don't need any value here, so we can use underscore for blank in range. And I'm going to put just 4, but this is going to be how many different sizes of particles. believe that's how we're going to use this. Yeah. Yeah. Okay, so I'll show you what I mean by that right here. So if I say for I and color and enumerate colors. Okay, so if you're not familiar with enumerate, you can loop through an iterable and have an index variable as well. So color is going to be what it gets from colors, our list, and then I is going to be what loop it's on. Okay, so we're looping through colors. That means that we're doing the first, what is it? The first layer of particles, so the smallest particles we have. So we're going to say, this is where we'll determine the radius pretty much. Radius int equals I plus 1, because I is going to start at 0 because it's an index. So we'll say radius is I plus 1, and then, oops, we need to make a modifier. I'm going to call this the rate of change percentage. It's going to be a float, and it's going to take a base velocity. Okay, so right outside this loop, I'm going to set a variable, call it velocity, and I'm going to 20, yeah, assign it to 20. So this is going to be our base velocity. This will be, 1 is going to be the initial radius. The rate of change percentage is going to be determined by our base velocity and our radius. So I'm going to say velocity divided by radius, and then divide that by velocity. And that'll give me a nice little percentage to modify particles that are bigger than the smallest particle we're going to use for this effect. So the smallest particles are going to have the fastest movement, the fastest dissipation, and then the slower ones will, of course, dissipate after. So we have for each layer, we want to have a particle for each direction. So that's what this next loop is going to be. We're going to populate each direction. So maybe I can give you a little bit of a visual here. Yeah, so loop, this first loop we're doing here, oops, where'd it go? There it is. The first loop we're doing here is going to be, yeah, you see how there's a little particle? And they're kind of the same distance from the center, right? So that's like one layer. That's the first loop is 1. The second loop is going to be putting that particle in each position. So next layer, next loop, boom, next layer, next loop. Okay. So we're going to loop through the directions now because that has the number and what we need to send them on their way. So for direction in directions, we need a slope. So we're going to calculate the slope and then create our particle. So for direction in directions, we're going to make the slope of the particle. So tuple equals, okay. For X, I'm going to do direction 0, because that's where the X modifier is, times it by our velocity, and then times that by the rate of change. And that'll give us our X. Now for Y, we're going to do direction 1. So the y position direction times velocity, and then times that by rate of change percentage. Okay. So the first loop where I is going to equal 100%. It's going to go, the smallest one, it's going to go 100% of the value. Each one after that, it's going to decrease. Okay. Slope, and now we have everything we need to start populating. So our list that we made right up here, particles, that's what we're going to append to. So we're going to say particles dot append. We're going to append a particle class. Okay. So now we need to pass our color, which we enumerated through up here, colors. So we can just put color right here. Next is going to be center, which is going to be our position. That's going to be a vector 2, which comes from Pygame. We imported it up here. We'll pass this our argument that we got, the start position. All right, that's where we want it to go. Oops, I want to use keywords. There we go. Color, center, vector. Yep. Okay, so now we need slope. And that's going to be just slope. And now we need radius, which is going to be what we called radius. Okay, now we can get out of the scope of the loops and we can return the particles. Particle list. Okay, so yeah, that's it right there. If there's, you could have wrote anything you wanted here, and as long as it returns particles, it should show up just fine. But yeah, if there's any questions on it, let me know real quick. Okay, let me hurry up here. So we just need to do a couple more things. We need to import this method here. We want access to that. So we're going to import effects. And then we need to have a way for managing our effects. So what I'm going to do is I'm going to make a list called live particles. And these are going to have all the active particles. So this is going to be a list that I can add to with these methods or these functions that we wrote. And then when the alpha reaches a certain point, which is 0, that we put in the property in the class, then we can check for that and remove it from the list. Okay, we got the list. We got events here. So we're going to say, we're going to go into the events loop right here, and we're going to check for user input so that we can send these ourselves. Elif event.type is equal to Pygame dot mouse button down. Then we want to extend our live particles. And we're going to use extend because extend takes an iterable. And that's what we're going to get from these functions. So we can say, oops, effects dot, and then start position. So any mouse button down event, the event class is going to have a position attribute. So we can just pass event dot position POS, and that will give us what we're looking for. Okay, so now we have the particles being populated. Now we need to draw them and delete them. So if, let's set a condition for this. If 0 is less than the length of live particles. So if there's not even any particles in this list, then we can just skip it over. If there are, we need to loop through them. particle and live particles. And we need to call the update method. All right, so the first thing we want to do is update and then draw. Update and then draw. So we update it. If the alpha is 0, then just remove it. And then pass it in. Else we can draw it. So this is how Pygame has one method for this. Pygame dot draw circle. You can also draw, ellipses and rects. There are different other things you can draw. Right now we're going to do circle. And then you see how it takes all these arguments. These are the ones that we specified when we made our class. So the surface to draw to, which for us is going to be display. Our color is going to be particle.color. The center is going to be particle.center. The radius. And then that should be all we need. The rest of these are optional. So, okay. Any questions so far? Right now, we're right here at the end of the time. That should be it. Let's give this a go. And there we go. It's coming up. It's very quick, but we can modify that. And you see how it's just randomly shooting colors.
That's awesome.
Yeah. Thank you. Well,
Great job.
yeah. Is there any questions on it or anything?
Any questions for Chae, anyone?
So how would you change the time that they take to dissipate?
Yeah, there's a few different things we can do. The first thing we should do is set up a clock real quick. So if we make a clock, Pygame has a clock object, pygame.time.clock. So we can make an instance of this clock object, and then every loop in our while loop, right at the start, we can say clock.tick, and we can pass that a frame rate. So if I put that at 60, we can launch the window again, and you see how it's going just a bit slower. It's capped at 60 now. I can come back here and I can drop it to 30. And now it's even slower, 30 frames per second. So that is something you should set first before you start tweaking the math of your equations. Because uncapped, you never know what you're going to get. It's just going to run. You would have to go off a timer or something different. That back at 60. Yep.
Any other questions, anyone?
Actually, yeah, I've got one question, Chae. I don't mean to put you on the
Sure.
spot, but do you have any games that are available to play online that you made?
I have projects. I don't have games. Not like full games in the sense that you probably are thinking. I do this to get better at programming, so I don't go through and just make games from start to finish in an engine or anything. It takes me so long just to make a menu. So this is pretty much just for, getting better at programming. But I do have a platformer I built with a few gameplay elements. I'm still working on that. And that Space Invaders demo I showed you.
Okay, very cool.
Yeah.
Yeah, I fiddled around with Pico 8, which is the fantasy console that uses
Oh, yeah.
Lua. And I was actually excited about tonight, and it was a great presentation, by the way. But I've been trying to port a few of my games from Pico 8 over to Pygame. So this is a great step in the right direction for me. So I appreciate it.
Yeah. If you need, any additional help, just shoot me an email, and I'll get back to you. I love Pygame. I don't know what it is, but I spend a lot of time just messing around in here and building things. So
Very cool. Yeah, I'll reach out with some questions. I'm sure I'll have a few for you.
yeah, my email's on my GitHub as well. And let me not forget to link the repository. There it is. So that will be all the code that we have here, except way more comments. Yep.
Any other questions, anyone? Okay, thanks so much, Chae.
Yeah.
I learned a lot. I think this is the first time we've seen data classes in Michigan Python, so that was great. And even showing things like enumerate and yeah, property getters and setters and showing how Pygame works. It was really great. So thanks for going through that. Really appreciate it.
Yep, no problem. Definitely reach out to me if you guys are interested in Pygame, because I'm just enthusiastic about it for some reason. So yeah, I'd love to help anybody out who wants to get into it.